Hi, my name is Robin Bublitz, and this is my presentation on the geological history of Iceland. First, I'm going to talk about the present location of Iceland. Iceland is an island that has two tectonic plates, Eurasian and North American. These plates are visible above ground. The ridge that splits Iceland is the Mid-Atlantic Ridge, also known as the MAR. The Reykjanes Ridge is the only part of the MAR that is visible above ground in Iceland. Iceland is the center of the North Atlantic Ocean, and the coastline of Iceland runs about 6,542 kilometers. So the general mineral composition of Iceland is mostly made up of basaltic mineral composition, and this is formed from the magma when it is cooled and it solidifies. Volcanoes produce this magma, and that's what solidifies and forms the Iceland's basaltic mineral composition. And the history of Iceland. Iceland is approximately 18 to 25 million years old. It started forming, though, around 60 million years ago. And 60 million years ago, the Mid-Atlantic Ridge gave away. This is what formed mantle plumes from volcanic activity that rose over the ocean to form the crust and the ridges. And then about 30 to 40 million years ago, the volcanoes caused the Mid-Atlantic Ridge to separate Greenland and Scotland. The land became flooded with water. In 10 to 15 million years, the Arctic body of water flowed into the Atlantic, submerging these regions. Once these regions separated, this left behind an island that we now call Iceland. The geological mechanisms. Iceland's incredible geological layout was formed from the volcanic process. These are responsible for its rift valleys, geysers, hot springs, rhyolite mountains, columnar basalt formations, lava fields, and lunar-like craters. In the northern and southern parts of Iceland, subglacier volcanoes have created table mountains. I've included some diagrams. In the top diagram, you can see the red solid line that shows the rift zones of the volcano. And then there's the dotted line in between, and this represents the fracture zone from interconnecting earthquakes. And the diagram below, you can see the volcano action that happened below Iceland, and that's the magma rising to the surface. And the volcano in Iceland caused the Mid-Atlantic Ridge to rise up to the surface of the ocean. These divergent plate boundaries cause large amounts of magma to be produced and rise up. The island is continually being pulled apart, as seen in the diagram. And Iceland's current situation. Iceland is still growing every day because the point where the two tectonic plates meet is constantly splitting. And this accounts for about 5 centimeters per year. Iceland is prone to many natural disasters, such as storms, floods, earthquakes, volcano eruptions, landslide, and even avalanches. So therefore, the population that live there, they must always be prepared for disasters. And the future of Iceland, due to global warming, the glaciers and the ice are all beginning to melt. If the glaciers do melt, this is going to cause the land to rise above the sea level. And glaciers are also responsible for cooling the volcanoes. So if the glaciers are not there to cool the volcanoes, then there will be more eruptions that may occur in the future. And that is my presentation on Iceland.